look up at the night sky. Take a moment to let your eyes adjust to the darkness and let the vastness of the cosmos sink in. On a clear night, far from city lights, you'll see a faint, milky band stretching across the heavens. This band is a window into the heart of our galaxy. That's the Milky Way, our home galaxy. It's a sprawling collection of stars, planets, and cosmic dust, all bound together by gravity. But the Milky Way is just one of billions upon billions of galaxies scattered throughout the vast cosmic ocean. Each one is a universe unto itself, filled with wonders and mysteries. Imagine a boundless sea dotted with countless islands, each teeming with its own unique features and inhabitants. This is a fitting analogy for the universe we live in. A universe of islands in space, each one a galaxy. Each galaxy is a cosmic archipelago, a collection of stars and planets. Galaxies are vast collections of stars, gas, dust, and dark matter bound together by the invisible hand of gravity. They are the grand structures of the cosmos. They are the fundamental building blocks of the universe, the cosmic cities where stars are born, live out their lives, and eventually die. These stellar metropolises are the cradles of creation and the graveyards of stars. Some galaxies, like our own Milky Way, are majestic spirals, their arms adorned with glittering stars and glowing nebulae. These spirals are the pinwheels of the cosmos, spinning gracefully through space. Others are massive, elliptical giants containing trillions of stars but lacking the intricate structure of their spiral cousins. These elliptical galaxies are the ancient behemoths of the universe, their stars packed tightly together. And then there are the irregular galaxies, cosmic misfits that defy easy categorization, their shapes sculpted by galactic collisions and internal upheavals. These galaxies are the rebels of the cosmos, their forms shaped by chaotic forces. But how did these magnificent structures come to be? What cosmic events and forces gave rise to such diversity? What forces shaped them into the diverse array of shapes and sizes we observe today? The story of galaxy formation is a tale of cosmic evolution, driven by gravity and the interplay of matter and energy. In this cosmic journey, we will delve into the fascinating world of galaxies, exploring their origins, their evolution, and their ultimate fate. We will uncover the secrets of their birth and the forces that shape them. We will uncover the secrets of their formation, the intricate dance of gravity and matter that gave rise to these cosmic islands. This dance is a delicate balance of forces, creating the structures we see today. And we will journey to the distant past, to the era shortly after the Big Bang, when the first seeds of galaxies were sown. This was a time of great upheaval, as the universe expanded and cooled, allowing galaxies to form. So fasten your seatbelts and get ready to explore the universe's grandest structures, from the elegant spirals to the massive ellipticals. Each type of galaxy has its own story to tell, a chapter in the cosmic saga. The journey will take us billions of years back in time and across unimaginable distances, all to understand the awe-inspiring story of galaxy formation. This is a journey through time and space, revealing the wonders of the universe. Let's begin by getting acquainted with the different types of galaxies that populate the cosmic zoo. Each galaxy is a unique entity, a vast collection of stars, gas, and dark matter, bound together by gravity and exhibiting a variety of shapes and sizes. The most familiar type and arguably the most beautiful is the spiral galaxy. These galaxies are the pinwheels of the universe, with their stunning luminous arms spiraling out from a central bulge. Just like our own Milky Way, spiral galaxies are characterized by their graceful swirling arms, where stars are born in vast clouds of gas and dust. These arms are regions of active star formation, glowing brightly with the light of young, hot stars. These arms are not static structures but rather waves of density that propagate through the galactic disk, triggering the formation of new stars as they go. It's a dynamic process, a cosmic dance that continually reshapes the galaxy. Next we have elliptical galaxies, the elder statesmen of the galactic population. These galaxies are often older and more evolved, having used up much of their gas and dust in earlier star formation. These galaxies are smooth and featureless, lacking the spiral arms and active star formation of their younger counterparts. Their stars are typically older, cooler, and redder, giving elliptical galaxies a more subdued appearance. They resemble giant cosmic footballs, containing trillions of stars in a tightly bound spheroidal shape. Despite their lack of new star formation, elliptical galaxies are massive and can dominate their local regions of space. Elliptical galaxies are thought to be the products of galactic mergers, where two or more spiral galaxies collide and coalesce, their stars settling into a more stable but less visually spectacular configuration. These cosmic collisions can take billions of years, resulting in the smooth, featureless appearance of elliptical galaxies. And then there are the irregular galaxies, the rebels of the galactic realm. These galaxies do not fit neatly into the categories of spiral or elliptical, and their shapes are often chaotic and distorted. These galaxies defy easy categorization, their shapes often chaotic and distorted. They can be the result of gravitational interactions with other galaxies, or they may have formed in regions of space with uneven distributions of matter. Some irregular galaxies are thought to be the remnants of galactic collisions, their spiral arms ripped apart by the gravitational tidal forces of their companions. These interactions can leave behind a galaxy that is a jumbled mix of stars, gas, and dust. Others may have simply formed in regions of space where the distribution of matter was uneven, leading to an irregular distribution of stars and gas. This uneven distribution can result in a galaxy that lacks a clear structure or shape. But what determines the shape and structure of a galaxy? Why do some galaxies form as graceful spirals while others become massive ellipticals or chaotic irregulars? The answer lies in the complex interplay of gravity, dark matter, and the initial conditions of the gas and dust from which the galaxy formed. The answer, as with so many things in astronomy, lies in the invisible hand of gravity. Gravity is the force that pulls matter together, shaping the structure of galaxies and determining their evolution over billions of years. Gravity is the architect of the universe, the force that sculpts the large-scale structure of galaxies and determines their ultimate fate. It is the invisible hand that guides the formation and evolution of galaxies, creating the diverse and beautiful menagerie we see in the cosmos. To understand how galaxies formed, we need to rewind the cosmic clock back to the very beginning, to the era shortly after the Big Bang. This monumental event, occurring approximately 13.8 billion years ago, set the stage for everything we observe in the cosmos today. In the first fleeting moments of the universe, everything was hot, dense, and rapidly expanding. The universe was a boiling cauldron of energy, with temperatures so high that particles could not yet form stable atoms. The universe was a seething cauldron of energy and particles, a chaotic soup where matter and energy were constantly interacting and transforming. This primordial soup was a mix of quarks, electrons, and other fundamental particles, all jostling in a high-energy dance. But within this primordial chaos, the seeds of structure were already being sown. Minute variations in density, almost imperceptible at first, began to emerge. Tiny fluctuations in the density of the early universe, imprinted on the fabric of spacetime during the Big Bang itself, provided the gravitational scaffolding upon which galaxies would eventually form. These fluctuations were the result of quantum perturbations, magnified by cosmic inflation. These density fluctuations, though minuscule, were enough to cause matter to clump together ever so slightly in some regions, while other regions remained relatively empty. Over time, these small differences would grow, driven by the relentless pull of gravity. As the universe expanded and cooled, gravity began to exert its influence on these density fluctuations. The cooling allowed particles to slow down and begin to coalesce under gravitational attraction. Regions of slightly higher density attracted more and more matter from their surroundings, growing denser and more massive over time. This process was slow but inexorable, as gravity continued to pull matter into these growing clumps. This process, known as gravitational collapse, amplified the initial density fluctuations, transforming them from faint whispers into the seeds of galaxies. The regions of higher density became gravitational wells, drawing in more matter and growing ever larger. Over millions of years, these clumps of matter continued to grow, pulling in more and more gas and dark matter from their surroundings. Dark matter, though invisible, played a crucial role by providing additional gravitational pull. As the gas collapsed inward, it heated up, eventually becoming hot and dense enough to ignite nuclear fusion in their cores, giving birth to the first stars. These stars were massive and short-lived, burning brightly and then exploding as supernovae. These stars, clustered together in massive groups, illuminated the early universe, marking the locations of the first protogalaxies. Their light began to ryanize the universe, making it transparent to radiation once again. The cosmic dawn had arrived. This era marked the transition from a dark, opaque universe to one filled with light and structure, setting the stage for the formation of galaxies, stars, and eventually, planets and life. While we can observe the luminous matter in galaxies, the stars, gas, and dust, there's an invisible component that plays a crucial role in their formation and structure: dark matter. Dark matter doesn't interact with light, making it invisible to our telescopes. However, its gravitational influence reveals its presence like a ghost orchestrating the cosmic ballet. Imagine a spiderweb, its delicate threads tracing out a complex pattern. The threads represent the dark matter, its gravity shaping the visible matter, the stars and gas, that cling to its structure. Dark matter forms a vast, invisible halo around galaxies, providing the gravitational glue that holds them together. Without dark matter, galaxies would fly apart. The visible matter alone doesn't possess enough gravity to keep the stars in their orbits. Dark matter's extra gravitational pull keeps everything in check, allowing galaxies to maintain their structure and evolve over billions of years. Scientists estimate that dark matter makes up about 85% of the total matter in the universe. While we can't see it directly, its influence on galaxy formation and the large-scale structure of the universe is undeniable. Understanding dark matter is one of the biggest challenges in modern astrophysics, and its secrets hold the key to unlocking a deeper understanding of the universe we inhabit. Thank you for watching. If you love space facts, hit that like button and subscribe for more cosmic wonders.